Okay folks, example number 9, it says in a canoe race, a team paddles downstream 480 meters in 60 seconds. Okay, remember it's just distance and time. Don't let it, just because it's not miles an hour, it doesn't throw us off, okay? Still using the same formula. The same team makes the trip upstream in 80 seconds. Find the rate of the current. Okay, now let's do this. We've got downstream, we've got upstream. We know that it's going to be rate, time, and distance. Rate, time, and distance. Now downstream, we know that the distance is the same for both trips, right? Same thing, they went downstream, then they turned around and came back upstream. Okay. We don't know what the rate was going downstream, okay? But it's R plus the current, right? Because it's going with the water, all right? And we know that the time was 60 seconds. Now upstream, it's their rate minus the current, and it takes them 80 seconds. All right, well let's do this. I know that 60 times R plus C is equal to 480. I know that 80, 80, Mr. C, 80 times R minus C is 480. Okay, now you know what, I'm going to make this problem a lot simpler for us. I'm going to divide both sides of this one by 60, okay? And that means that's going to give us the 60s cancel here and leave us with R plus C is equal to 8. And then over here, I'm going to divide by 80 on both sides, 80, and R minus C is equal to 6. Now, we've got a system of equations. It looks like adding and subtracting would be the easiest thing to do. Just put one right above the other. I like dividing these things up into 3 columns. I'm going to get rid of the C's. I'm just going to add, okay? So R plus R is equal to 2R, and 8 plus 16, 8 plus 6 is equal to 14. Divide by 2, and the rate is equal to 7. Now that's the rate that they're paddling, but it says find the rate of the current. Well, the current, remember, R plus C is equal to 8. So 7 plus C is equal to 8. C must equal 1. And that's our answer. Okay? Nice. Nice. I love those current problems. Distance equals rate times time. We know that. All right? Let's look at the next example, or the final example. Oh, this is one of those easy puzzle problems. The denominator of a fraction, okay, so we know it's going to be one of those fraction problems. I like to just remind myself of what I'm doing. It's a fraction problem, numerator and denominator, okay? And it says that the denominator of a fraction is 9 more than the numerator, okay? That means the denominator is equal to the numerator plus 9. So I can write it as n over n plus 9, all right? If the numerator is decreased by 3, n minus 3, and the denominator is increased by 3, n plus 9 plus 3. Okay? The value of the resulting fraction is 1/4. Okay? What was the original fraction? Well, that's what we're looking for. Okay? Let's simplify this thing. First off, it's n minus 3 over n plus 12 is equal to 1/4. But I've got a fraction equaling a fraction. I'm going to cross multiply, right? N plus 12 times 1, well that's just n plus 12. And then 4 times n minus 3, we'll distribute that. So we're going to get n plus 12 is equal to 4n minus 12. Okay? All right. Let's, I'm going to get the n's together. You know I want to get variables together first. So now I've got 12 is equal to 3n minus 12. Add 12 to both sides. And I'm going to get 24 is equal to 3n. Divide by 3. And I'm going to get n is equal to 8. All right? So now our numerator, we know the original over here The numerator was 8. And they told us that the denominator is the numerator plus 9. So 8 plus 9 is 17. Now let's see if our fraction satisfies the conditions. They said if we decrease the numerator by 3, well, that would make it 5. And we increase the denominator by 3, which would make it 20. Okay? Does that give us 1/4? Sure, it does. All right? So our answer is 8 over 17. Nice job. You guys are ready. You guys are doing so well with this stuff. Remember, this whole chapter, this whole test is going to be about systems of equations. All right? Great job. You're ready. Study hard.